Here's a problem in statistics that I do not solve all the way through. What I do is the parsing of the question at the beginning, and that takes a while. So here we go. Here is a problem in logistic regression. They're studying the probability of a heart attack given your age and whether you take aspirin. And they present 5 different models. The first model has no variables at all. The second model just uses aspirin. The third uses 3 age brackets: less than 40, 40 to 50, and over 50. The fourth model uses aspirin and age. And the fifth model includes interactions, where age 1 is multiplied by aspirin and age 2 is multiplied by aspirin. And they give the log likelihoods of each of these models. Now, the interesting issue is with the wording of the question and the wording of the response. The first part of the question said, test the null hypothesis of constant aspirin heart attack odds ratio across age strata. And their answer key started off with, this is equivalent to testing the interaction terms. And I said, wait, how did you get there? There are a lot of steps that they skipped. So here's it expanded out a bit. What we are doing here is a logistic regression. In a regular linear regression, you are saying that y is beta 0 plus beta 1 x1 plus ... etc. That's a regular linear regression. A logistic regression is when you say the natural log of y over 1 minus y is equal to beta 0 plus beta 1 x1 plus etc. Putting a function of y instead of y is called putting a link function. And this link function in particular has the name the logit, L-O-G-I-T. So first of all, that's our setting. This is the full model they're talking about, model 5, that includes all the variables. Now, let's look at this mouthful. The null hypothesis of constant aspirin heart attack odds ratio across age strata. What does all that mean? A quick reminder. The odds of something is the probability of it happening divided by the probability of it not happening. And the odds ratio would be odds divided by odds for 2 different situations. For example, taking the aspirin versus not taking the aspirin. So that's first of all what they mean by odds ratio. Aspirin heart attack, the heart attack is the outcome variable that we're finding the probability of. The input variable is the aspirin. We're comparing, do you take aspirin versus don't you? In logistic regression, the linear expression is equal to the log of the odds. So if we want the odds, we would do e raised to that linear expression. And so the odds that y equals 1, you have a heart attack, given that aspirin equals 1, age 1 is 0, age 2 is 0, you're younger than 40, would be this expression. Plugging in 1, 0, and 0, most of the model cancels out. And we're left with e to the beta 0 plus beta 1. Likewise, we can find the odds of a heart attack given no aspirin and younger than 40. When you plug in all the values, you just get e to the beta 0. So finally, the odds ratio would be e to the beta 0 plus beta 1 divided by e to the beta 0. And that would be e to the beta 1. Now that was assuming the person is younger than 40. What if we did it again, assuming the person was between 40 and 50? The odds ratio for heart attack versus aspirin, if you're in your 40s, age 1 equals 1 and age 2 equals 0, when you plug in e raised to the linear expression, plugging in aspirin equals 1 gives us a beta 1 here, and age 1 gives us the beta 2, and since aspirin and age, their combined term beta 4 also shows up. But if aspirin is 0, the only things that aren't zeroed out are beta 0 and beta 2, so that when we cancel everything, we get e to the beta 1 plus beta 4. Similarly, if we just did age 2 instead, the odds ratio is going to be e to the beta 1 plus beta 4. Now, we finally have the equipment to address the question they're talking about. Test the null hypothesis of constant aspirin heart attack odds ratio across age strata. In other words, they're testing the null hypothesis that e to the beta 1 equals e to the beta 1 plus beta 4 equals e to the beta 1 plus beta 5. So in other words, we're testing the null hypothesis that this equals this equals this. But that simplifies to saying that beta 4 is 0 and beta 5 is 0. And so finally, after all that, we can in fact conclude what they're asking for is whether the interaction terms in the full model are 0. And then there's further information for performing the actual test. But this was an exercise in parsing the question, figuring out what they're actually wanted to know.